Dear world, welcome back to the Java collection classes, and in today's session we'll be studying the Java TreeSet. So first we should understand what is TreeSet. As we have previously discussed that set TreeSet is actually a partition or type of set. This is a division of set, that is TreeSet. So in TreeSet, in case of set, we always observe that set contains the unique elements. But in TreeSet, the most important thing is that TreeSet contains the sorted elements. That means if we insert objects or elements in the TreeSet, it will automatically get sorted. So let's look at the features. Object of TreeSet class are sorted in ascending order. That means if we insert elements in the TreeSet 1, 2, 5, so it will get sorted in this manner, that it will get sorted in the manner 1 to 5. TreeSet always contain unique element like HashSet. Like HashSet or all other sets, it always contains the unique elements. TreeSet, the access time is fast access and retrieval time. Because the TreeSet uses internally the binary trees, that's why here the access time is fast. It doesn't allow null elements. In TreeSet, we cannot insert null elements and it is non-synchronized. So it's implemented using cell balancing binary search tree like red black tree. So it is actually implemented using binary tree, and we know what is type of binary tree. So these are the methods of tree set: add wall, e-shilling, descending iterator, descending set, head set, pole first, pole last, subset, is empty, remove, clear, clone, first, last, etc. So we'll observe, we will look all of the methods one by one with example in details. So let's move to the TreeSet file. This is TreeSet. We will work in this directory. So look, this is the directory where we'll store our file, and this is the Java collection framework. So we need to change the directory. So command that is change directory, TreeSet. Now code TreeSet1.java. So we will be creating the first file TreeSet1.java. Import dot star public class TreeSet1. Look, the file name TreeSet1 and this file name, the class name and the file name should always must be same in case of Java. Public static so we declare the main method here, and this is public, that means the file is public. Static, so that our main method can be accessed from the compiler without creating object. So this is static. The return type is void, that means there will be no any return type, and this is the main function. So let's create our object of type integer. Treeset of type integer, shed new treeset. Now look, we created the object of set, and now we will be adding elements in this set. So we will randomly add the elements. Set dot add. Let's say we are adding 20. So this is 20. Shade dot add. We are adding 1. Shade dot add. We are adding 15. Shade dot add. We are adding, let's say, 599. Set dot add. We are adding 40. Share.add, we are adding 5, 2. So look, we actually added all the elements, and when we'll print the element, we'll see that all the elements will get automatically sorted and in the ascending order. So this is the main thing what we'll observe here, and using the dot add function, we can add all the elements here. So let's check. System dot out dot print ln set. And now for running the file, first we need to compile the file. So we'll be compiling the file. Java compile -d, that means directory, dot, that means current directory, file name treeset1.java, Java treeset. Now using Java we will run the file, and now you can see, observe, this was our insertion order, but in the tree it got inserted in this manner, in this sorted manner. And the main thing is that we cannot insert any null here. If you try adding any null elements, let's try adding null 0. So this is null, and let's again try compiling. So it actually added the 0, but it will not add the null. Add null. So you can see that we can only add the 0 for once. And look here, it's maintaining the unique elements. We cannot duplicate any element. That means if we add set.add 5 again, it will always maintain the unique elements. It will not add the second duplicate elements. Again we will be compiling the file, and again we will run the file. And look, again there is only one. So from here we can see that here in sets only unique elements are added. And let's check by adding the null. That means we cannot add something like null here. Okay, we'll come later in the discussion. So this is add method we observe. So this is add is done. Now we how we can add, now we will be observing add all method. So let's make another set. This is set 1. Now let's make TreeSet integer set 2 new tree set 2 dot add 20 set 2 dot add 21 set 2 dot add 22. So these are the elements of set 2. System dot out dot println elements of set 2. Now we will be adding all the elements of set 2. So for adding all the elements of set 2, we can use the add all function. What we can use? We can use the add all function. So we will add with set 1, adding all the elements of set 2 with set 1. So here we'll be adding with set 1. So we have to use the set 1 first. So look, set 1 dot add all of all the elements of set 2. So here that set 2 will come, and now if we check, all the elements of set 2 will be printed. System dot out dot println, after adding all the elements of set 2 with set 1 and now we will again compile the file. Java compile -d dot tree set 1 dot java. Cannot find symbol set 1. Look, here we got a error that it cannot find symbol set 1. We got the error set 1 because here we have used the set. We have declared the object as set. So let's change this to set from set 1. This is set, and this is also set, and this is also set. So this our set 1 is here known as set. So now we will not get the error. Again compiling the file, and now we'll run the file. And now look, after adding all the elements of set 2, all the elements got added and in the ascending order. Look, all the elements are in the ascending order, and 20, 21, 22 it got added, but in the ascending order, correct position. So this is the add all method, that using add all we can directly add the entire set with some existing set. Now after add all, we'll be observing ceiling. So ceiling is actually a method. It returns you elements. Ceiling actually returns the equal or closest element of the specified element from the set, or null if there is no element. So while using ceiling, we have to provide an element, and it will return the element equal or the greatest element of that. So let's check ceiling. System.out.println checking ceiling method. Set.ceiling, and let's say we're writing 10, and now let's again compile. And now look, we got the closest or greatest element. That means if we use 10, it will check if 10 exists here or not. And if 10 exists not exist here, it will go just above that element 15. So what if we print here 16? Suppose if we print here 16, so we will get the element 20 here. So 16, let's again check 60, and now again compiling, running. And now look, we got the element 20. That means it checks exactly near that element or the element above it. So this is a scaling method. So after scaling, we'll observe the descending iterator. You might be wondering what is this descending iterator. So before descending iterator, we need to understand iterator. Iterator is actually iterator is belonging from the class iterator, from where we can actually iterate the elements one by one. And in descending iterator, we can iterate the elements in descending order, that is in reverse order. So let's check this iterator. Let's make a object of iterator. Iterator itr equals to set dot iterator, while iterator dot has next system dot out dot println iterator dot next. Iterator iterating using iterator. Okay, now we are using iterator. We are making iterator object. Once we make object, all the elements of set comes into this iterator. And now iterator, now we are using our while loop here iterator dot has next checks if it is having a next element, and if it is having a next element, that is if it returns true, then it comes here and it then prints the element, and again the cursor moves to the next point, that is pointer moves to the next one. So this is the iterator dot next function. So again we will compile the file, java compile. And now it will print all the elements. So we'll be running the file, and now you can see it was printed all the elements one by one iterating. So descending iterator will print the element in the descending order. So let's check this one, iterator itr2 set dot descending iterator, and we will again use the same method, iterating using descending iterator. Iterating using descending iterator, descending iterator. So look, while iterator dot has next, now we are assigning all the elements in the iterator 2. So we'll be using iterator 2. Now again we'll compile the file, and now you can see all the elements got printed in the reverse order. In the reverse order, all the element got printed. So this is the descending iterator function of TreeSet class. So what is this descending set? If we use the descending set method, then all the elements of the set will be printed in the descending order. We can check this, system dot out dot println set dot descending set, and now again we will run it, and we can see all the elements got printed in the descending order. So this observing the HashSet method. So HashSet element actually returns lesser element than the specified element. Whatever the element will be specifying here, it will return the lesser element. So let's check it. Control C, Control V, set dot head set, head set, and let's say we want to get the elements only below 200. So this is the our top head. So we'll be again compiling the file, and now you can see only elements that are lesser than 200 that got printed, and in the ascending order, because this is the default order. So this is the set dot head set. Now let's move to the next method. Headset is done. So using the poll first method, we can extract if you want to get the first element. Suppose we want to get the first one element. So for getting the one here, we can use the poll first method. And suppose we want to get the last element. So for that, we can use the poll last method. Then let's check the poll first and poll last method. System.out.println set dot poll first. So this will give us the first element, system.out.println set dot poll last, and it will fetch as the last element. So let's again compile the file and check the elements. And you can see we got 0. Here 0 is the first element, so we got 0. And this is the last element, 599. So we got the last element here. Suppose we are making this set as 1000. So you can understand we'll get the entire set then. And now you can see 599 is our last element that got printed using poll last method. So this is poll first and poll last. What if you want to get element between a specific set? For that you can use the subset method. So let's look. Suppose we want to get only the elements between 5 to 40, and for that we can use the subset method. So again we'll be printing the element using subset, system.out.println set.subset 5 to 40. And now again we'll compiling the file. Now you can see only the elements that were between 5 to 40 that got printed. It started from 5, 15, 20, 21 and up to 40, but not including 14. That is, it printed starting from 5 up to 40 but not including 40. So this is the subset. Using subset method we can get subset. So this is tail set element. It also similarly returns the top element. Contains. Using contains we can check if our element exists here or not. So let's print system.out.println print element set dot contains. We are checking if it contains 40 or not. It should return us true as 40 is in our list. So again we will compiling. Java compile. Now we'll be running the file. And now we can see we got true cause 40 is present here. What suppose if we use 41, we'll get false. Again we'll be compiling the file, running the file, and we got false because 41 is not present. So this is contains element. Is empty similarly return if the set is empty, it will return true, and if the set is not empty, it will return false. So this is empty method. Let's check is empty also. Is empty and remove. So let's check system.out.println checking is empty set.isEmpty. So we will be genuinely getting false because the set is not empty. So let's check compiling and Java. False, we got false. Suppose you want to remove the element 0, 1 to 3. So we can remove the element using remove function. Set.remove 0. It will remove 0. Set.remove. It will remove 1. It will remove 2. Let's remove all the elements. Set.remove. It will remove 5. Set.remove 15. Set.remove 15. Now removing 20. Set.remove. Removing 21. Set.remove. Removing 22. Set.remove. Removing 40. Set.remove. Set.remove. Removing 599. So now we removed all the elements. Now we will check if our isEmpty gives what. Now our isEmpty should give the true because the entire set is true. So let's again system.out.println checking if empty or not, if empty or not. Okay, then we will be printing set.isEmpty method again, and it should return us true. Java compile, Java run, checking if empty or not, and it's true because our entire set is now empty. If we again write that system.out.println set, then there will be no elements, and you can see we got empty set, that is there is no elements. So this is clear. Using clear we can by directly we can clear all the elements. Using clone we can clone all the elements. If you use the first method, similarly we will get the first element like 4 first. Using last we will get the last element, and using size we will get the number of elements in the set. So let's check the size. System.out.println printing the size of the set is set dot size, and it will return us the size. Now we'll be compiling and then we'll be running. The size of the set is 8. That is, in our set there are total 8 elements. So this is all about the tree set. We observed all the points about tree set and the main methods add all. We add all, ceiling, descending iterator, descending set, head set, pole first, pole last, subset, tail set, each empty, remove, clone, clear, etc. All the method we observed. In the next session, we'll be observing queue and priority queue, DQ, Java maps, etc. So we are ending the tree set here. We're ending the session. Thanks for enjoying it. Please do subscribe.